It's my pleasure to introduce our new work on causality and submodularity. So our paper entitled Causal meets submodule, subset selection with directive information. So in this paper, we consider two important problems related with subset selection. So the first one is what we call causal sensor placement. This is shown in the left-hand figure. And the second one, we call it causal covariate selection. And this is shown on the right-hand subplot. Both of those two problems encompasses many real-world applications, including computer science, biology, and social science. Since we are dealing with causality, the first question we have is, how do we characterize causality from data? So in literature, there are two ways to do this. So the first one is usually called Grange causality. Essentially, it reduces causal identification into a prediction problem. So usually it's also called prediction causality. The second one is usually called counterfactual analysis. This is like more consistent with our common intuition, but usually it's harder to compute from data. So in this work, we use a tool from information theory, which is called directive information. So the advantage of using that is that direct information can capture nonlinear causality from data. And also it admits well-established parametric or non-parametric estimation methods. And moreover, we can show that direct information is actually a special case of Granger causality when log loss is used for time series data. With direct information as a measure of causality, we can formulate the causal sensor placement problem as maximizing direct information from selected set to its complement, subject to some cardinality constraints. Similarly, the second problem, causal covariate selection problem, can be also formulated as maximizing direct information from the selected set to some target process, subject to some cardinality constraints. Both of those two problems are actually NP hard. In order to solve these problems in a tractable way, we conduct submodularity analysis for these two problems. For those of you who are not familiar with submodularity, you can think of it as a general property for set functions, and it's the so-called diminished return property. Fortunately, we can prove that the first objective function for causal sensor placement is actually submodule. However, the second problem, causal covariate selection, is not submodule in general. The counter example can be found by using the causally explaining away effect into the random process. However, in practice, we also realize that in many cases, although the function is not strictly submodule, they are very close to submodule. So that's why we are motivated to define a new term called submodularity index to characterize the strength of submodularity for general set functions. So essentially, we can show that a set function is submodule if and only if its submodularity index is positive. With the newly introduced submodularity index, we can prove performance bound for greedy heuristics for like a much broader class of set functions. Our main result is summarized in Theorem 1. Here we can see that our bound consists of two parts. So the first part is the bound from classical literature. And the second part is actually a function of submodularity index, we just introduced. So in this way, we can see that actually we can apply greedy algorithms to a much broader class of set functions. And also, it implies that submodularity is actually continuous property for general set functions instead of like black and white definition. To complement our theoretical result, we also conduct a bunch of numerical experiments. Our result is shown in this figure. And we can see that the greedy heuristics works pretty well, even for functions that are like approximately submodular. And also, it is seen that the performance bound obtained in this work is a much better guarantee compared to previous results. Finally, we also show that the problem of causal graph construction can be reduced to causal subset selection problems. And we also conduct a series of experiments to justify this procedure. And the results are shown in this figure, figure 3 and figure 4. That concludes our presentation. And you can find more results and interesting discussion in our paper. So I really encourage you to read through the paper and contact us if you have any questions. Thanks for your attention.